Hi, welcome to flexiWAN Academy. For our fourth lesson, we're going to be covering configuring application-based routing in flexiWAN. So let's get started. In this session, you will learn how and when to configure application-based routing using path selection. So we will be covering a number of areas of path selection, specifically what path selection is, how it works, its relation to path labels, its relation to an introduction to application identifications. We will also be covering quality-based routing. And finally, then we will demonstrate how to create these path selection policies and how to install them on FlexiEdge devices. So let's get started. I'll minimize this. And first, I'll, as always, like to start from our Academy pages. Please check out flexiwan.com/academy, where you can see all the previously held lessons. And we will also plan to update after this session. Today, we will add more upcoming sessions, so you can sign up and watch. So, as always, let's start from FlexiWAN documentation. docs.flexiwan.com is a place that you want to always start when learning FlexiWAN. And for today, we have a very nice section added about path selection. Of course, I didn't click path selection. Yeah, here we go. So path selection, we cover in great details most of the things that I'm going to mention today. So I definitely suggest that after this, watching this lesson, definitely check out also documentation pages so you can get a much better also insight, deeper insight. But today we're going to do the high level overview, to say. So we can switch to FlexiManage, which is a central management platform, and we have already known 3 devices that we have used for our previous lessons. So basically, on them, we will have a hands-on learning session about how to learn how to utilize path selection. So what's path selection? Path selection basically enables application-based routing with FlexiWAN. With path selection, we can allow users to route outgoing traffic across specific interfaces or across specific tunnels. In a nutshell, that's it. You just route all outgoing traffic towards an area where you want to, whether that be specific tunnel, multiple tunnels, or a specific interface. I'll also just briefly mention that path selection includes quality-based routing, which is more for sensitive application categories, such as like video calls, for example, the Zoom call, which we can then use a much more sensitive mechanism prevent of gathering statistics of the links, so we can have like seamless failover or across multiple WANs, so the calls does not, or video calls don't get dropped. So moving forward, path selection itself relies on multiple features. By itself, path selection can be found here under path selection policies. And we will be covering this section, of course, a bit later. But path selection itself relies on 2 components, and this is something that we covered in a previous session about tunnels, which I recommend that you check out. This is a path labels page, and path selection actually utilizes path labels, and this is actually how path selection policy can specific configuration of the policy. For example, we want to route specific traffic across specific interface. We then actually route specific selected traffic, or all, doesn't matter, we'll show that later, across specific path label. So this is why it's important to already have or create path labels and already have some knowledge about them. So please definitely check out the path selection. Path labels video tunnels video, which is a previous video. So path labels can be can be DIA, direct internet access, or used for internet breakout. And the second type is the tunnel path label. So these are the path labels that you use to connect multiple sites together. And we use these path labels for a more granular approach to connecting tunnels. All of this is, of course, covered in the previous video. But the way it works, and I'll demonstrate this later, is that path selection relies on path labels as a as a primary way to route all outgoing traffic. And as a secondary second feature it relies on is application identification. So what is the application identifications? You can go here to traffic and app identifications. This is a built-in database of all popular ranges or services or applications. And all of these, and you can view the categories here in the other columns, contain the ports and IPs of popular applications, popular ranges. For example, Cloudflare. If you can click here, then you will see all the possible ranges. You can see there's actually many number of IP ranges, and we already have our own internal classification for Cloudflare and their ranges. And of course, this means category security, service class is default, importance medium. However, all of this can be changed. You can, if you feel that this is incorrect, that you want to prioritize or lower priority, you can make all changes here. But to move one step back is basically with application identifications, every single every single entry in this table is considered application identification. And it can be, as I said, the public ranges, but it can also be, for example, let's do the BGP. It can be specific ports. And so it can be IP-based or port-based or both. You can even add your own when you create a new app identification. And you can, for example, if you have importance, you can order by importance, and then you will see what is considered high importance. And this area is very important to check out. So to memorize, basically, categories are category itself, service class, and importance. Because later in the video, I'm going to show you how to route specific outgoing traffic per either specific application or per specific category, service class, or just importance. Ideally, you want to, and the fastest way is to just use the importance category, because it's already predefined, and then you can just route all specific traffic of high importance across the high quality link, traffic of low importance across the low importance, like backup link, and so on. But we'll touch that a bit later. So one last thing is, the custom app identifications offer the ability to create your own list of IPs or ports, your own ranges, your own external ranges, your own or public or internal ranges. So, and not only to be used with path selection, it can also be used with firewall. For example, you can have a list of firewall. For example, there is a Telefonica ranges rule called, so I want all these ranges, to be able to, I could create a firewall rule to say all these ranges will be allowed or denied to access a specific flexiWAN instance. But we plan to cover firewall also in a much greater depth in the upcoming video, in the upcoming lessons, just so you know. So moving forward, these are the app identifications. So these are like signatures, which containers of all the IPs and ranges that then you can use to route specific outgoing traffic through. And finally, I want to touch briefly just on quality-based routing. There's a little nice diagram here in our documentation. Basically, this is flexiWAN path selection uses several ways to route traffic. You can, and I'll show this a little bit later in the video, but one is you can do priority, which is big across multiple links, which is basically a failover. You can do load balancing across links, and finally you can do quality-based routing across links. So the purpose of this is actually to utilize QBR with more sensitive applications, time-sensitive applications such as video calls, anything that basically requires, faster user experience. For example, seamless failover. And I'll show briefly this in a video in our lesson later on how to achieve seamless failover with flexiWAN, because it involves a little bit of planning, but nevertheless, it works actually great. So basically, the purpose of quality-based routing is to provide a good equality of experience for each application, and unlike the other two ways that we have, which are mostly just going to monitor the link, but if they see the link is down, they will switch to the other link, and if the first link comes back up, they will switch back to it. And you of course can imagine that this, if you're in a voice call and a video call, this will affect your experience, user experience. But with quality-based routing, we do this much nicer, because we gather in a much nicer and smoother way. So we gather much more statistics, much more loss and delay related statistics. So we switch even before the link goes down. We detect that link is deteriorating, and we say, okay, let's switch all the traffic to the second tunnel or the second link. And in that case, even before the primary link goes down, the traffic will be sent to it, to the secondary link, and user will not really even experience any kind of issue. And what the interesting part is, we will then, even if the first link comes back up, we will still, which is this last feature, this last note here, is that prevent path flapping. Basically, that even if the first link comes back up, we're not going to switch when using QBR. We're not going to switch quickly back to it. Instead, we will wait for it to come back at 100% to stabilize, and then we can say, okay, this link is ready to be used back again, and we'll switch back. So, but this is just I wanted to just explain a little bit about how quality-based routing works. We will, of course, cover several use cases during this video, including the one for quality-based routing. So let's dive in. We explained to summarize, we explained that path selection itself relies on multiple features, multiple other flexiWAN features, which one of them is path labels, which are used to logically identify or label. Think of it a specific interface. Think of it as you have a label maker, and you type name of the interface, or link or ISP name, and stick it to the network port. That's exactly that. It's completely logical entity, meaning that it does by itself, it doesn't do anything. But when used for tunnels or when used with path selection, then it shows the true power. So it shows you can see the true power of path labels. So yeah, the second feature that it relies on is traffic and app identifications, which is our built-in database of custom application signatures, custom and built-in signatures, which can be popular public ranges, popular applications, ports, and so on. And you can add your own. So let's go back here to just to get acquainted with the layout. We have 3 sites. We will consider Tel Aviv as a central site, because it has dual WAN, and we will have New York, which is it's a remote branch New York site, and it has a single WAN. And also, if I'm not mistaken, Tokyo has also Tokyo has 2 WANs. Although actually in this case we're not going to use it, so I'm going to disable it. So it's going to also have single WAN. Hopefully this change will not break anything in the demo, but let's see. And we have tunnels established for now. Doesn't matter in this case. I can even remove them, but because we're not going to use it for too much in the demo, in the lesson. Yeah. So moving forward, yeah, Tokyo will come back right in a few moments, because we've made a change to interfaces. Here we go. So we have these 3 devices, and they at the moment have no policies installed. And we have a specific use case where we have Tel Aviv site, not use case, we have a Tel Aviv site which has dual WAN. And let's say that 82.10 is the primary link, which indeed is, because it has the lower metric. So the lower the metric, the higher the priority. And the 84 is the secondary link. So first one can be fiber, the second one can be coaxial or LTE, anything you would like. And we would like to route specific traffic across these primary interfaces and secondary interfaces. So basically, to start, you need to make some plans. Planning first before deploying path selection. As said, path selection requires path labels in order to operate, because path selection itself will use path label to route specific traffic across it. So let's get started. Let's go to path labels page, and here I have several labels already created. One is the DI, some types actually, and we have tunnel labels, and we have DIA, which are the breakout labels. So you can create path label by clicking on new, and you can enter the name and the color, even description. Be very creative with descriptions and names. We can call it can be path label only for a specific application. Of course, it's not recommended, but you can really name any kind of path label. So moving forward, in this case, we will use pre-configured path labels, and these are ISP1, ISP2, and we will use primary and secondary DI label, which themselves show you if in the description can be seen here. So we will apply these to the primary side first, and also I'll remove the tunnels because they're not necessary at the moment. And let's go here. So the primary path label, ISP1, this is a tunnel label, and primary, this is a DI label, as explained previously. So now this interface has two labels. One is the tunnel label, the other is the internet breakout label. Why? Because now we can, once we assign these path labels to the interfaces, now we can route specific interfaces, route specific traffic, across specific interfaces thanks to these path labels. So let's also do this. So like secondary label and secondary ISP. So now the interfaces are labeled, and we can click. Let's update the device, send down the information down the API, and now the device is syncing, and in a few moments it will be synced. But this is not, in this case, this is very specific to this device, this configuration. But we will probably have multiple sites. So if you want to enable, if you want to have to connect using the tunnel labels, so if you want to connect to tunnel labels to other site, if we try that now, if we try to connect New York to Tel Aviv across ISP1 and ISP2, nothing will happen. And this is because, as explained in our previous video, we haven't really assigned any path labels to the other end. So you can only connect tunnel, just to recap, you can only connect established tunnels to the site, to the same path labels. So this is what I was referring to, some planning. You want to create some plans. So in this case, let's also create ISP2 and also actually assign ISP1 and ISP2 path labels to this interface. So this device will be able to establish tunnels to both primary and secondary tunnels of Tel Aviv site. And also here, I mean, we can, but we don't really have to. We can assign primary and secondary, just primary label, because we have just single WAN in this case, at least that's assigned. Excuse me. So now that we have assigned path labels, let's show some path selection magic. This use case, we can cover several examples. So let's get started with the policies. So to create an actually path selection policies, and yeah, path selection actually it works by in a way that you go here and you create a policy, and then just in a similar way as we create tunnels or add firewall rules, you just select devices that you want to utilize, on which you want to install path selection, and then under actions you select install policy, select path selection from the drop down, and choose the route. Choose the path selection policy that you created. I'm not going to do any of these predefined. We'll build one from. We'll build several from scratch. So to recap, we did already path labels, assigned path labels to both devices. So now it's time to actually create the path selection policies. So we click new policy, and you can basically, let's go have a small description of all the elements first. So let's go through all the elements, and to explain also the purpose of this default rule, and then we can come and talk about the examples of what to do. So the policy, the policy name and description is self-explanatory. You can basically, we definitely suggest that you make and add names that are, very understandable and also provide description as always. The way it works is, so we will show the academy, name it. And my suggestion is also do this first. Of course, add a rule or enable and then save the policy. Don't bake huge policy without saving it, because you may close the window or something and then you'll have to do it all again. But of course, you require one rule first. So I'll touch the default rule in a few moments. Let's now talk about how to add a rule. So you click the plus sign. So now we come back to the point of application notifications, because here you can, by default, we have a small mode, like a fast way to deploy pad selection rules, which is the this smaller window, and you add for example, first rule. I know it's not that imaginative. Of course, it's enabled by default. And category, we can remember that we talked about these categories on the traffic and app identifications. So you can create you can pick a category like media, and then comes the path labels requirement, which we already did assign. And we said, okay, I want to route all media related traffic across secondary, and you click add rule. So that's it for the very basic and first example of how to actually add a rule, outgoing grab. So right now, and when you expand the rule or even expand all rules, you can see that here in the description that we are routing whole category media across secondary interface. Of course, you then want to go back to the traffic and app identifications, and you can expand this list, and let's go find the media category. Here we go. So media category is all of these Teams, Zoom, Netflix, real-time streaming protocols, SIP, RTP, Viber, but you can also add your own additional custom app IDs, and then add them also to the media group. So this is why it's important to first check and see all this list before using pad selection. And here you will be able to view on this list. We can see the rules, and now we added the first rule. But what about other ways, other categories? That's also possible. But for that, let's call this rule advanced rule. There's also advanced mode. When you set advanced mode, this will enable advanced mode. This will show you the full true power of pad selection. And here you can actually use multiple traffic classifiers to route either per name, application name, which is specific application, for example, Netflix. And it's also searchable. If you start typing YouTube, actually start typing Netflix, it's listed there. And you can do basically any kind of, you can even add your own custom applications. If you actually even first list the custom ranges, for example, or stuff. But let's focus on let's do Zoom, and you can create a now you can create a policy that uses application name, a specific application Zoom, and here under action you can have you can select actually the path labels that you want this traffic routed to. So for example, ISP1. And I want to route all Zoom traffic across ISP. No, actually, that's not across primary, which is the primary link, which is the more sensitive link. The fiber link, which is always on, or has higher SLA and so on. And here you will see that all the orders will be grayed out except the fallback action, which is a very interesting feature. By default, if you keep it by destination, what will happen is flexiWAN will try to route this traffic across the label across the interface that has the primary label assigned. And if the by destination is kept by default, assuming that the primary link is down, meaning that the primary label is not reachable, we will just, flexiWAN will just use any other available interface on that device. So whether that be secondary, third, or the interface that you haven't even assigned, the interface that you haven't even labeled actually, but yes, assigned, has to be assigned to be used with flexiWAN. It will route across any other available interface if this primary is down. But if you click here and select job, what will happen is traffic comes to outgoing traffic from the LAN side comes to flexiWAN. flexiWAN tries to find the interface labeled primary, and if the primary interface is down, it will, instead of routing all the traffic to the secondary interface, it will just drop the traffic. This is the purpose of the fallback action. So it will make sure that if you want, like for example, you may have some sensitive traffic, and then you say, okay, I want to route only across this interface, so only across primary. So in case the primary is down, just drop all the traffic. And let's use this rule here. Also, later, just to point out, if you and you probably will do this at your own demo, at your own home lab or lab environment, or even in a production, make sure to test flexiWAN pad selection only from LAN clients. That's the place where it's applied. It is not going to be applied from if you test it on the Flexi Edge itself. If you log in like via SSH to the device, and if you try to do trace route or for some specific defined application or range, it will not apply. The pad selection policies are only applied on LAN side, not for the device itself. So yeah, moving forward, now we have 3 rules. One is the default one. The first rule we explained, we created one rule, which is just which basically is the category. So let's talk a little bit about other 3 categories. Actually, other 2 categories. So let's call this rule categories, and we covered the application name, which basically allows you to pick specific application and route it across a specific interface. Now let's talk about application categories. So again, the categories also are basically just these 3 here from app identifications, these 3 columns, and you can use for like management category, which then in this case includes let's find it. Hold on, I think I need to network control, signaling, media, high throughput, default. Maybe I should have picked the other one, or maybe I missed it. These are the default one. Yeah. Let me see. So the management are these categories, and you can create the same way. You can pick a specific category, pick a specific label, and you route all the management across specific label. But you can also say, okay, I want to also use only the default ones, and also you can do specific, more granular approach. You can say, I want to only route actually with high importance service class default and management categories. Actually, management category from service class default, and with high importance, I want to route it through ISP1 or any other label. This means, so basically this shows that you can use multiple different, combine these categories, but in most cases, what's really suggested is you can do just this. High importance, I want to use all the high importance traffic must be across primary traffic, and then you can click add. So let's rename this. So add it, and let's also add another rule, low importance, again expand, and you can say expand. Now you get the point. It's basically, we want to route all. Actually, there's a button, you can collapse everything faster. So we have high importance and low importance traffic. And here you can see that now as the rules are being added, that we have priority. So the way pad selection will process all of these rules, is that we will, Yeah. So is that we will the first with we will process from the top down from actually from the bottom to up, meaning that the lower priority that is going to is with lower number. So the low like rule number 3 will be below rule number 2. So rule number 2 actually will override rule number 3. Even if I had two same rules, one that says use the same category, use primary, in the same category use secondary label, because the second rule is on top, it will override the bottom one. And this is very convenient for combining multiple rules, but we'll touch on that a bit later. So moving forward, I'll talk about categories a bit, about prioritization later. So now we have created, we have used, basically we have shown what application name, routing traffic across application, using traffic classifiers, using application name, application category. Here, and we said that you can combine, use specific category, only specific class, or only specific importance, or just combine all three of them. And finally, you can just use pure IP rules. So you can say, 192.168/32, or you can even do whole ranges, and you can then say, I want to route all outgoing traffic to this IP across ISP2. Let's call this counting. So let's assume that the counting server lies in the 55 range, and we want all outgoing traffic, and which is and this rule is for like remote branch, and you want to route all the outgoing traffic across the ISP 1 or 2, and you add this rule. And finally, I will add again this rule just to point to one more thing. Of course, you can also say you can use like specific port range, or a specific protocol like only TCP, only UDP, or if it's not selected, if there's no selection, then all the protocols will be routed across specific path label. So now we have demonstrated basically all the traffic categories, but that's not it. This is just initial elements description. This is still not the actual examples of the policies, because we're still explaining and understanding how actually to utilize path selection in its full power. So let's take the high importance rule that we created and set the advanced mode. So this rule, the idea is you route all high importance traffic across the primary link. But here's the thing, using a single link is never going to be good for production environments, and you probably have multiple WAN links. So you want to, in this case, you want to route all outgoing traffic across 2 links, not just 1 link. So, and with path selection, that's exactly what you can do. So what you can say here, you can do primary, which is already selected, you have secondary, and now this selection order is no longer grayed out. So what selection order? Selection order helps you to decide between prioritization, which is actually failover, and then also you can utilize load balancing. So actually, to move one step back, I didn't provide too much information about failover. So meaning if the priority is selected, we will send traffic across the primary, and the order in which you select these labels here is important. So if you had selected primary first, then this will be the primary, and then if the primary goes down, it will switch to the secondary. All the traffic will use secondary. But the second option is load balancing, which load balances all the traffic across both links. This may help in some use cases, with some applications. And finally, the link quality, which is a quality-based routing feature, which is used for more sensitive application. In this case, you can use it even for high importance, but it's better to use it for like specific like Zoom category, or specific applications like Zoom or VoIP and so on. And then in this case, you can achieve seamless failover, because the way it works is in this case we actually load balance traffic across both links, but when link quality is selected, we load balance traffic, but we gather much more statistics about the link stability and quality and drop rate and so on. And if the primary starts to deteriorate, we will automatically switch to secondary, and the call, whatever kind of traffic is going, should not be interrupted because we're using load balancing. But in case the primary comes back up, we will wait for it to be fully stable, 100% backup, and then we will switch back to it. That's the trick with the link quality. So now I've explained the purpose of, so now I explained how you basically can how you can use selection order to achieve load balancing, prioritization, which is failover, and also utilize link quality, which is QBR. Let's keep this as a prioritization, click update rule. So once you create a policy, once you install a specific, once you are satisfied with the specific policy, be sure to save the policy. And that's it. Now you can see the list of all the policies that are installed, not installed and created. And you can actually see where it's installed. It's not yet installed. So it's nowhere installed. So let's basically cover, just recap what we did. So we covered all the ways, all the possible rule options. We covered that you can use several traffic classifiers, whether that be application name, which you can use for a specific application, or you can use a specific category, service class, or importance. Don't forget, we recommend just utilizing importance because it's the fastest way to get your network organized, outgoing traffic, or specific IP rules, which can be specific internal or external IPs. And then you can route access to some IP across specific tunnel or specific interface. We also covered on how to use the path labels and how to actually decide whether to use prioritization, link balance, load balancing, or link quality across them. And we covered also fallback option, which when drop is selected, when any of these interfaces are not available, all the traffic will be dropped instead of sent across any other interfaces. There's also a plus sign here, which can offer here a much more advanced. You can basically create multiple groups of path labels, and then you can even load balance or prioritize across these multiple path label groups. But this is a little bit advanced for this specific lesson, so we're not going to use it. But yeah, this is how to create a policy, a specific policy. So once you create a policy, and here we have a number of policies, you have to actually install it to a specific device. So this is what I wanted to focus also a little bit on. We have created a policy which will for a device that is, in this case, New York, and the device itself is the device itself is a branch site, and because it's branch site, the Tel Aviv is the main site with all. Let's think about that like this is the main site, and it has all the main. It's a data center, and it has servers and accounting server and all the things that we defined. So we we have this site, and right now there are no tunnels. So let's create also tunnels. So we'll create tunnels between Tel Aviv and New York. Don't forget we assigned that. Did I assign actually? Yeah, I have assigned. Yeah. So now we can create tunnels between New York and Tel Aviv. Now the tunnels will be added. Again, we covered tunnels in a great depth in the previous video lesson. Be sure to check it out from the Academy pages or from my YouTube channel. So now the tunnels will establish very soon. So now we have the branch site and DC site. The policy that we just created is in this case, we showed many examples, but let's assume that this policy that we created is for the New York site, meaning that we have defined a policy that will access accounting server only across specific interface or specific tunnel. And once you create a specific policy and once you're satisfied, you have to install it to a specific device. You can install it to all devices, but it's no use of creating a policy of installing one policy that's intended to be for branch, that you install it also for the main site. Instead, what we recommend is you can have a policy for all the branch sites and a policy for all the data center sites or all the core sites. So in this case, we can create one policy for Tel Aviv and the other policy for New York. And here, the way you install the policy, it's the same way as with tunnels or creating tunnels or firewall rules. You pick a device you want to install the policy on, and from the action button, you click install policy, you pick the path selection, and here it is. This is an academy, and you click install. And that's it. It will create a job. We've covered also how jobs work in our first webinar, I think. Basically, everything you do, everything you click on in an interface and send a job, it will send the instructions down the API directly to device using secure socket connection. And that's it. Basically, now if you go to jobs, you will see that the policy academy has been installed. And this is how it works. And now if you go to New York and if you click to policies, you will see that this policy is actually indeed installed on this device. And if we move back to path selection, you can also see now the status is installed. From here, you can also, if you have, now imagine if you have hundreds of devices, instead of searching which specific device has this policy installed, you can just click here, show all devices, and it will show you here how New York has the filter. And this is basically using our filtering feature, which basically allows you to filter using all of these specific attributes. So yeah, New York now has the policy installed. We just showed you how to install the policies. And now, yes, I want to cover one I forgot to cover. I showed you how to create rules. So we've seen how to create specific, use specific categories, applications, but I didn't demystify the default rule. And actually, let me create a new rule for this new policy. And again, when I create a new policy, every policy comes with the rule called default, and there is it's not enabled by default. And when you click on it, you also don't really have all the features, all the features that you can you've shown with other rules. And if I click advanced mode, nothing happens. It will not allow you even. So the purpose of this rule is basically to create, to capture all the traffic that is not matched by any of the other rules. And actually, maybe I shouldn't have created a new rule. Let's actually use the academy rule. By default, the default rule will always be at the bottom, which is this. So as we kept adding the rules, the default rule was just going down to the lowest destination. And remember, we talked about how flexiWAN processes the rules. Every rule above the previous one has higher priority. So if the default rule is, so the default rule basically serves as you define a number of rules on the top rules, route specific traffic across specific or all traffic across some interfaces or path label or tunnels. But you cannot really, you didn't define everything. You didn't, these are rules that are focusing on specific categories, ranges, and so on. But with the default rule, you can, by enabling the default rule, then you can decide on what to do with all other traffic that is not defined. So this shows this allows you basically to say, okay, I defined, things that I want to do. I defined the traffic that we need to route specific interfaces or tunnels, but for all the other traffic, I would like to load balance it. And of course you can. You can say primary, secondary, and now all the traffic that's not matched by any of the rules above will be also load balanced. And so basically this rule acts, the default rule acts as a catch. It catches all the other traffic that is not defined and applies a path selection policy to it. So what I'm going to also demonstrate now is, I'm going to click save and update device. Remember, this Academy path selection policy is actually already installed, and but we first installed it, then we edited it, and so what happened? It was actually very fast, so we didn't really see, but in the background, you can see that we had the policy installation 5 minutes ago, but then a second ago, we also have another installation. So this actually shows you that if you have a policy installed on many devices, and if you make any kind of edit to this device and you update the save, and if you update the device, if you save the policy, you can see here now it doesn't say, it just shows save. It shows save and update devices. It will push all the changes automatically to the device or to the devices that have this policy installed. So that's also a very neat feature because you can then make changes on the fly without having to reinstall the policy. We will automatically update devices and automatically we'll create a job. So without any user input, that's how it's going to work. So yeah, that recaps all the elements and in general how path selection works. So let's now talk about examples, specific policies that I wanted to create, and just to to show you, I'll use a few just fast examples just to show you how to utilize path selection to the best to the best practices for path selection. So let's create a new policy, and let's talk about internet backup. So IB Academy. Here we can say, we can create a rule, and let's just focus on internet backup. In this case, let's create a rule which will be high importance, and select primary, because primary label is the internet breakout, and pick here high importance. And also, by fallback action, if you remember, we said that if the drop is selected, if the primary interface goes down, the traffic needs to be dropped instead of passed through any other available interface, which makes sense in this case. High importance traffic is something that you probably feel like it's high important, and you want it to be used only across the more stable link. Primary link is more stable. I mean, this is just an example. Okay, the point is that you can to understand what's the purpose of the drop. Then let's add another rule. And again, let's use traffic of low importance. Actually, no, let's use traffic of medium importance. And you can again see what the medium is, medium category, actually no, medium importance. Oops, I'm clicking on the wrong thing. This is the medium importance traffic. And you can say, yeah, I want to route all that traffic across the secondary traffic DI label, and I want to keep the fallback option as destination, meaning that if the secondary is down, it will just route it through across the secondary interface. But here, this is why it's important. So, for example, what I was talking about regarding the priority to fallback action. Now, in these two rules, which when you expand them, you can see that all the primary traffic will only use the primary label, the primary interface. If it goes down, the system will drop actually all the traffic. It will not send it to the secondary. So this is why it's important to understand the purpose of the drop category. And and in this case, even if I was to say do the same thing to drop, and then here in this now because the drop fallback action is selected, the primary traffic label will only use the primary interface, and the secondary label traffic will only use the secondary. So if any of these goes down, traffic will be dropped. So this is for some traffic that like in this case, if you don't want to route traffic across specific other interfaces except this interfaces, this is how to achieve it. But let's do, for the purpose of not confusing people, let's just allow all the traffic. And now we have a rule to, whoops, I selected the wrong rule. Destination. So now we have two rules. We have primary traffic will go across high importance link. High importance traffic will go across the primary link, and the medium will go across the secondary link. But let's use the low importance rule and enable it. Don't forget to enable it. Don't forget, you cannot click advanced mode. And let's do primary, secondary, load balancing. So every other traffic that we didn't define, remember, we only defined high traffic and medium traffic, importance traffic, the other two rules. We want to say all the other traffic will be load balanced across primary interface, and I did not enable it. Don't forget to enable. What? Didn't even say. Yeah, I probably didn't click something. And I think I have a cache issue, so let me just save this page. Example, no, this was the wrong policy. Here we go. So I think it should allow me to do something. This is a demo. Demos are, all other. Demos can sometimes be predictable. It doesn't allow me in this case. Sorry about that. This appears to be probably some caching issue in my system, but you get the point. All the traffic will be now, all the traffic of this device can be routed across the, all the other traffic that's not defined will be load balanced or prioritized across. So this is in a nutshell the example of the internet breakout. The tunnel routing works the same way. You create a new policy and tunnel, and you can say, okay, I want, for example, counting. I want a counting application, all traffic towards this specific port, specific protocol to be ISP1, to be load balanced across primary and secondary interface. Actually not, primary and secondary load balanced across first and second tunnel labeled ISP, from the first ISP and the tunnel from the second ISP. So now we have an example basically on how to route specific outgoing application, which is most commonly used use case where you route ISP1, or when you route accounting access to accounting server across primary and secondary tunnel, and actually load balance it. So in case the primary goes down, the traffic will just use the secondary without even any kind of interruption, to put it like that. What's also possible is you can also use the default rule for this, or any kind of other advanced option to route across the tunnels. We're closing to an hour, so I'll do it a bit quickly. So we have also a number of predefined policies. For example, load balancing. You can create a policy that basically load balances traffic. Actually no. So what's possible also to do is, and this is what I wanted to show, is basically to route all traffic across a specific tunnel. So this is the rule that I created. So in this case, what we can do is we can, if we expand this rule, this policy will actually route all the branch outgoing traffic. So from the LAN side, all the traffic will be load balanced across the tunnels. So all outgoing traffic will use both tunnels, whether prioritization, using prioritization or load balancing or even link quality. And actually LAN clients, if you install this rule to, for example, if we install this rule to New York, and by the way, you can overwrite a policy by doing this. You just install route, you pick a path selection, route via tunnel, and you click install. So now the system will actually, to New York, it will now change. It will override the previous policy, and now the new policy will be used. And now this all traffic from New York will actually be routed across, will exit using the Tel Aviv IP. This is a very common use case, use case that our customers and clients use, is they use path selection to route all traffic across specific devices. So LAN clients would have external IP of whatever the data center IP has, and it will use data center as internet breakout. That's the important part to point out. This is the purpose of the route all via tunnel. And finally, to finish this demonstration, I wanted to show you just basically, we don't have too much time to show you how actually this can be done, but the quality-based routing functionality, which we talked about, which is used for more sensitive, time-sensitive applications such as Zoom calls, videos, video conferences, or any kind of very high real-time traffic, high importance real-time traffic, we recommend using QBR. And in this case, you can say, call this policy. Let's make it let's a nicer name. Let's call it Zoom. And in this case, you can create a new rule, and also again in advanced mode. And here you can pick application name also Zoom, and you can say, okay, I want Zoom to be load balanced, not load balanced, but sorry, link quality, to enable link quality, which means quality-based routing, to utilize quality-based routing, to install, to use, to route all Zoom traffic across primary and secondary tunnels. So the assumption is this: we are installing this policy to New York device, and New York device has a single ISP provider. Actually, no, not, I apologize. We're installing this policy to Tel Aviv in this case, and Tel Aviv has dual WAN. So we want to utilize, you want to utilize QBR for multiple, on the devices which has two or more WANs. So in this case, Zoom will be using link quality, which actually does load balancing across multiple links, but we just gather more statistics. And if with the system detects that the primary system is deteriorating, the primary tunnel is deteriorating, we'll switch the secondary. And in practice, basically what this means is that the end user will achieve seamless failover, because the traffic will be going will just, even without the traffic will not have any kind of interruption, should not in theory have any kind of interruption. Instead, it will switch to the secondary interface, and the call will just move without any kind of interruption. And just to point out, I'm using, in this case, I'm using tunnels. And the way it is, this feature is actually used for seamless failover correctly, so I can save it. So the idea is this: Tel Aviv. Let's go here to notifications network. The idea is this: Tel Aviv has dual WAN, true dual WAN, and New York is in this. Let's change the scenario a little bit. New York has is a data center, and Tel Aviv is a branch, and we want to route all. We want to achieve seamless failover for specific, time-sensitive applications, real-time applications. So, and we have two tunnels, primary and secondary. So we say, let's configure two tunnels between Tel Aviv and New York, and let's create a path selection policy with QBR, which uses a specific application such as Zoom, and it will route Zoom across these two tunnels. And thanks to the QBR, once thanks to the QBR, once the primary link goes down, the Zoom call will continue, and there will be no interruptions. And why is that? This is because the traffic is not actually using the local internet breakout. Zoom servers will keep seeing the same one IP all the time, the external IP of New York. So this is a trick actually to achieve seamless failover with flexiWAN. You just use two sites, and in today it's very easy to get affordable even VPSs or Amazon-based VPSs or cloud-based Amazon EC2 instances, which have more better stability and better uptime. And our suggestion is basically to use two sites for achieving true seamless failover, because in this case you actually have a third. We have two IPs, local, two public IPs in Tel Aviv, but the New York itself has one IP. So if the primary goes down, the traffic will switch to the secondary, but the Zoom servers will not see this change. So they will still be receiving the traffic from the New York. So end users will not have any kind of interruptions. This is the trick for seamless failover. And yeah, basically with that, I think we can start to close this session. Hope it was informative. Now in the last section, we covered multiple examples. We covered, and multiple also, layout, the whole layout, about everything, about how pad selection elements work and which features you have. Of course, we will be uploading this video shortly. So if you have any questions, feel free to contact us. And yeah, let me just see. Yeah, I didn't mention that you can ask questions during the call, but nevertheless, in this case, I think we can close. So thank you all for attending. Be sure to subscribe to our other upcoming webinars. We will be covering peering, basically connecting to third-party sites or clouds using peering and IPsec. We'll be covering firewall. We also plan to have a session on troubleshooting tunnels. If your tunnels are not connecting, we'll show you how, and in general, how to prepare this environment for, to prevent any kind of issues with tunnels and so on. So yeah, with that, I think we can close. Thank you all for attending, and talk to you in the next Academy video. Thank you.